Good morning. No radio alarm saw video today. In fact, you probably won't see me in the video today. A friend of mine, younger friend, who had never built a set of stairs, asked me if I would create a little tutorial using SketchUp to show him how a set of stairs is to be constructed. Over the years, as a young carpenter in the apprenticeship program when I was 18, over the next 40 years, I probably drove nails into at least 1,500, maybe 2,000 houses, and a good portion of those houses had stairs in them. And early on, I decided to learn how to build stairs, and I had some pretty good teachers back in the early days. I was a little stubborn in most regards, but when I wanted to learn something, I was generally all ears. So anyway, I had some good instructors, and then scads of experience after that. I drew blueprints on a couple of hundred houses, and so I also learned how to draw them correctly. So this is kind of the culmination of, close to 50 years worth of being involved in framing houses, building stairs, building roofs, etc. So here we go. First page. I need to get my mouse where I can click pages. So there, on the first page here, what we have is just an overall view of the stairs. And oftentimes what limits the rise and the run, what determines the rise and the run is the space that you have between an opening and the top landing. The opening down here and the top landing up there. Sometimes this can be, if you're drawing the blueprints, of course, you can make this whatever you want. But sometimes you're building a set of stairs on blueprints that somebody else drew, and oftentimes these guys just throw numbers at it, 7 and 10, or 8 and 10. And so they'll draw a set of stairs in there, 8 and 10. If it doesn't, they'll just shrink them down. Well, needless to say, a lot of draftsmen, a lot of architects have never actually built a set of stairs. So with that in mind, you'll have to learn how to make those adjustments in rise and run and still come up with a set of stairs that will work. Now, this set of stairs I drew with 14 risers at 7 and 11/16 and 13 treads at 10 inches each. 10 inches is pretty standard because your treads are made out of 2x10, 2x12s most of the time, or often, if they're going to carpet, or they're made out of hardwood, and that stuff will be anywhere from 11 1/4 wide. The thickness doesn't matter because you can make those adjustments. 11 1/4 wide by the length, and then there'll be 11 1/4 to 11 3/8. You might start off with 11 3/8 on a piece of Douglas fir, 2x12 for your treads, but over time that's going to shrink. So, it's going to shrink a 1/16 or an 1/8. So I figure 11 3/8, which gives you 3/8 of an inch, 1 3/8 of hangover where the tread extends past the riser board. Now, I normally frame my stairs out of 2x12 stringers, 2x12, in fact, probably 95% of what any stairs I ever built were made out of 2x12 stringers, 2x12 treads, and 1x8 risers. So that's it. The basic stair build is, and this ledger up here, I usually make that out of whatever, either a 2x12 or a 1x12, I'm sorry, a 2x12 or a 2x8 or whatever will fit in there. Or I just cut down a piece of the decking that we used up here on the upstairs deck on the wood floor. And oftentimes, if there's enough, I'll use that stuff for my treads too, but it's not as good as 2x12 because it won't span as far. You absolutely have to put a horse down the middle, which is a third stringer, down the middle of the stairs if you're going to use the plywood for your treads. Now, if this opening had been drifted to the left 10 inches, instead of being where it's at, it was over this way 10 inches, I would have gone with 14 treads and 15 risers, because that would have shrunk this down, I think, to around 7 and 5/16, which is, the closer you can get to 7, in my opinion, the better off you are. The closer you get to 8, the steeper the stairs are and the harder they are to walk up. Now, another thing is when you're cutting your stringers. Now, nobody does this. An old timer taught me this trick 45 years ago. When you cut your stringers, you got them all laid out. You used a square and some square gauges to lay out your stringer, and you got your pencil lines all on it. So when you cut the tread, you start above the line where the blade is just touching the line, and as you cut towards the inside of that notch cutout, you drift about 1/16 of an inch below the line. What that does is makes your treads tilt just a little like this. Now that's exaggerated. But when you're walking down those stairs, you feel like you're being forced to lean backwards. And when you walk up the stairs, you feel like you're leaning into the stairs. If you get them dead flat, that's okay. But if you were to get low on the nosing and high back here where the riser is, well, when you were walking up, you'd feel like you were leaning backwards. And you were walking down, you'd feel like you were leaning forward, being catapulted off the stairs. So it does make a difference. And if you think about it, above the line and then just about 1/16 below the line when you get to the riser. That way, this point and this point will remain at your 7 and 11/16. This point will be slightly 1/16 more than that. But nobody's going to notice that in looking at it. You'll only notice it when you're walking on the stairs. You might not want to do that if you're using hardwood and a lot of fancy trim. You don't want to have to deal with, you'd like to stick with 9 degrees here. Can you follow what I'm saying? Now, if your stringers are going to nail to a wall, I've never felt bad about running my skill saw by a little bit and by this way a little bit, because you still end up with about 5 inches of solid wood that you're nailing to a stud every 16 inches with a couple of 16 penny nails or long screws, or however, glue and screws, however you're doing it. And so you got plenty of support. Sometimes when I felt really fussy, wasn't in a rush, I would bring a jigsaw out, cut to the line with a skill saw, and then finish the cutout with a jigsaw. Either way is fine. So that's about enough on this page. Let's go to the next drawing. And here's the top landing. You can see that your 2x12 tread is 11 3/8, and like I said, that'll probably shrink a little bit, okay, over time. If you've got it anchored well back here, all the shrinkage will take place on that nosing and not leave you a big crack back here. There's your 10-inch from the face of this riser, which essentially is a riser, even though it's a rim joist. It's still it still acts as a rim joist riser here in this case. And so you're 10 inches. You can see this cut out 10 inches. You can see this notch cuts out 7 7/16. Those have to be marked out very precisely, and the mathematics has to be done very precisely. Otherwise, your stairs just won't be worth a hoot. You can't have your stairs, I've seen them, 7 1/16 all the way up till you get the last one and the guy screwed up, and the last one, instead of being 7 11/16, is freaking 7 inches or something, you know, or 7 1/4, or, you know, or 7 7/8. You can't have that. This has got to be as near to perfect as you can get it. You get that thing within a 16th or a 32nd all the way up, you're golden. Okay, this is the ledger I was talking about earlier in the first video, or first picture. I usually make that out of this material, or I make it out of a piece of 2x12 ripped to fit. I like to notch around it. I like to run screws or nails, preferably screws, through the back side of this ledger into these 2x12 stringers, and I always put liquid nails on every connection. If you don't know what liquid nails is, you can find it at any hardware store. It's a construction adhesive. It does two things. First of all, because you're cutting at angles, you're dealing with kind of half-assed end grain, which doesn't glue well with Elmer's or anything like that. So you need something good and thick-bodied glue. Liquid nails provides that. It does two things. If your cuts aren't perfect, it provides a cushion. So when you drive these nails in, it pulls up tight, and the glue kind of fills your little imperfections. You're not cutting this out with a. You could cut it out with a router. I've seen guys do it. I think it's too much work, but even then, it's only as good as the jig you made. So I use liquid nails everywhere. This joint between here, if you can see my pointer, this joint where the riser is connected to the tread, I like to screw or nail that with a bead of liquid nails across the back. Liquid nails here, about 3 screws down through the top. Liquid nails in this joint again, and then screws about every 8, 10, 12 inches, whatever it takes to get it to pull up tight. There's no sense overdoing it. So here's again is my note: cut stringers so that the treads are slightly low, 32nd of an inch plus, towards the upper landing. So that's what we were talking about, getting this slight pitch to the treads. Oh, I want to go back to the first drawing because there was something very important I missed there. When you get to be doing the math, all right, here's my measurement over here, 107 5/8. Now this can be mathematically calculated because you know how tall your studs are, you know this, but I like to just measure it, all right, at this point down to here. From the top of the floor at my nosing, don't forget when you deck the floor to leave that nosing stick out 1 3/8. From the top of this to the floor down below. Now, that doesn't guarantee that your math is going to work, because what if this floor is out of level and this is actually, at this point, is actually an inch lower, or a half inch lower, or an inch higher, or a half inch higher? Well, that has to be reflected in this 107 5/8. In other words, if this floor is 5/8 an inch higher than it is over here, then you're going to need to change this number from 107 5/8, and your math is going to have to be based upon 107 inches, not 107 5/8. So you need to get a straight 2x6 that will. What's the matter with this thing? Why is it doing that to me? Oh, I'm bumping the dang mouse. Okay, let me hit that button again. That'll bring it right back where it belongs. Okay, so. What was I saying? So you need to get this is 130 inches, right? So that's not quite 12 feet. It's a little less than 11 feet. So you get a 12-foot 2x4 or 2x6 that's straight, okay? And if it's not perfectly straight, put the crown up, put the level as close to center as you can imagine it being. And now you can measure, if you have to lift this end up, then this is high. If you have to lift this end up in order to get it level, this end is low. And you can calculate how much it's low or high and add or deduct that to your overall rise. All right, get the idea? So now we're at the top framing. And then we go back to, there's the bottom. Now at the bottom, you have to know that once you've laid out this stringer with all your pencil marks and stuff on it, you have to deduct the thickness of one tread. You have to cut it off the bottom of your stringer right here. Then notch it, and this 2x4 gets glued and nailed to the floor. If it's concrete, you might have to drill for some pins to go in if you're working on a concrete floor. But this, see, if you deduct that 1.5 inches, this is 6 3/16 rather than 7 11/16. All right, so that's important. The other thing too is if you're using 1x8, they might be just a little bit shy on the bottom, like an 1/8 or a 1/4. That won't bother anything. Just go ahead and make sure they're tight, they're even with the top before you put the tread on. Tight up here, it doesn't matter if they're a little shy in the bottom. Next picture. This is an under framing shot. There's your stringer nailed to the wall. Here's your other stringer. Imagine a wall there. There might not be, okay? Sometimes there's not a wall on that side and you have a hand railing, exposed hand railing. But generally speaking, most stairs will have a wall there. So at each stud in that wall, you need to put 2 or 3 16-penny nails and or screws, because you don't want this thing squeaking. You want screws going through here into this top tread. You want screws going through this. I mean, everything has to be screwed and glued. Otherwise, you're going to get squeaks over time. I know this from experience. I've built squeaky stairs before. We had to go back to them. Fortunately, they were carpeted. And I could run some big screws down through the top and get rid of the squeaks. It's mostly when I was using nails instead of screws. There's a perspective. It's pretty simple. The little notch down there where you're notching for your stringer. This is to keep this stringer so it's pinned in there. It can't come down as long as this can't move, right? So without that, the stairs could slip this way. You're putting a lot of stress up here. This way you're sharing the stress between here and here. It's actually pinned in there by gravity. The mathematics. Mathematics are not complicated. All you need is a simple 4-function calculator to do this. You know that the landing height is 107 5/8. Well, if you don't know how to convert 5/8 into 0.625, you just divide the numerator by the denominator, and it gives you that decimal point. So you divide 5 by 8, 5/8, divide 5 by 8, and that gives you 0.625. So your stairs is 107.625 divided by 14. I don't know if you can see that little mouse pointer. Divided by 14 equals 7.68764. I like to go out a few decimal points. It doesn't matter. They're on the calculator. You might as well use them. So now, once you've got that number, now you've got to convert this back into a fraction, because that's what your tape measure deals with. So you take the 7.68764 minus 7, which is that 7. That leaves you with 0.68764. Now you want to convert this into 16th, 32nd, or 64th. No point in going any better than 64th. In fact, you probably won't even go that fine, because that's cutting it pretty fine. So now to get this 11/16, you simply take this number times the denominator. So the denominator, 1/16, 16th is the denominator. So you take this decimal number times the denominator, equals 11/16 equals 11 equals 11/16. 11/16 plus 7 inches equals 7 and 11/16. It's very simple. I mean, nothing could be easier. So you end up with 14 risers at 7 and 11/16 inch, 13 treads at 10. I always use 10. Reduce the height of the bottom riser by a thickness of 1 tread. We went through that. So you got 7 11/16 for your normal riser, minus 1.5 inches for the thickness of your tread material. If you're using inch thick tread material, which is pretty common, you'd only deduct 1 inch. But in this case, 1.5 inches equals 6 3/16. You've got to get that. That's got to be done. Otherwise, the thing won't work. Okay. If you can get some sheetrock on the job site before you cut all the treads and all this kind of stuff for your stairs, sheetrock the stairwell before installing the stair stringers. It sure makes it a whole lot easier later you don't have to notch that sheetrock around all them steps. I mean, I've had to do that before, and then you got to tape around, you got to trim around. I mean, it's a big nightmare. Use liquid nail adhesive between all the connections. Nails are okay, screws are better, less squeaks. If it is possible to sheetrock the walls before installing the stringers, if it is impossible to sheetrock the walls before installing the stringers, fur the stringers away from the wall, away from the studs by 1.5 inches. So you can slip the sheetrock in, you can slip an apron board down in next to the stringers, so you don't have to trim all that stuff. Okay. If you need to sheetrock under the stairs, add a third center horse. Riser cannot exceed 8, but the closer you get to 7, the better. The closer you get to 7, the easier it is going to be to walk up those stairs. They're not going to be as steep. And if you can even go below 7 to about 6.5, if you've got the room. All right, unless there's openings or something in the way that prevent you to do something. So if you need to sheetrock under the stairs, add a center horse. Let's look at that thing again, the perspective view. Oop, not that one. Under landing. Okay. If you have to sheetrock under here, you can either run backing blocks between the stringers. What I normally do is just add a third stringer in exactly one of these stringers, an exact copy of it down the middle. All right, and I install it the same way I did the other ones with screws and glue and the whole bit. And that's not really called a stringer. The stringers are on the edges. This is called a horse down the middle. So you put a horse down the middle if you're going to sheetrock under it. Okay, now the last one, the calculator. To convert a fraction to its decimal equivalent, divide the numerator by the denominator. The top number is the numerator. To convert a decimal to a fraction, multiply the desired denominator by the decimal. The usual denominator in stair framing is 64th, 32nd, or 16th. 1/64th inch is cutting it pretty fine. Finer than that, most cannot cut using a circular saw anyway. But there is this, I was taught by a fellow that set forms for high-rise buildings, and the whole deal there was they tried to get as close to perfect as they could, because they knew that the forms would move a little bit when you put in that heavy concrete. So for him, he always said that cut forms for high rises, he tried to get it at 64th of an inch. Now, did he get that close? Probably not even before the concrete was set, but he attempted to get that close so that he wouldn't be a mile off after the concrete was poured. You can get the idea. So, like the movie that Mel Gibson was in, aim small, hit small. I think that's what he said in that movie. So that's it. I can't think of anything else that's important as far as stair building goes, except make sure you get the math right. That's all. make sure that you know when you're figuring your stairs. We go back to this overview. When you first start doing your math, you will divide the rise. First of all, you'll measure from here to here, and you'll say, look, I've only got 136 inches here, so I know I can only get 130 inches worth of risers, right? I mean, that's a given. You can't get 140 inches to stick out in there. So you know you can only get 13 treads on this thing, all right? From here, 1, 2, 3, 4, etc. 13 treads. You can only get 13. So if you have 13 treads, you know you have to have 14 risers, all right? So you know to divide this number by 14. But let's say the door was way over here and you didn't know whether or not you could get 15 or 16 in. Well, you'd start with 15, and if that fit, you got 15 risers, so you know you have 14 treads, so you're sticking out here. And now you can just calculate and look and see if you can get maybe one more in. And if you can, and it's not going to make it below about 6.5, well then go for it. If that's what you want to do. If you want more distance there between the opening and the stairs for some reason, well, that can be done too. So the only thing struck in granite, as far as I'm concerned, is that you can't be less than, you can't have a riser higher than 8 inches, and you can't have a tread in the rough, okay? We're talking about the cuts that you're going to put on the stringers. You can't be less than 8 inches here, and you can't be you can't be more than 8 inches here, and you can't be less than 9. If you make a set of stairs 8 and 9, it'll be perfectly legal, but it'll be steep, all right? Sometimes that's necessary. I've been in tight spaces in apartments where they just didn't leave a lot of space for stairs, and I've had to approach the 8 inches and approach down towards the 9 in order to fit the stairs in. You got to deal with what you got, and that's about that. So, if any of you have any questions, let me know, and I'll try to answer them in the comments section. So that's how you build a set of stairs. Sadly, I can't see, you might use a radial arm saw cutting those treads and those risers, but probably if you're in the field, you're probably going to use a skill saw or circular saw to cut all that because it's rough framing. You're going to put carpet over it. If you're cutting a set of stairs out of hardwood, you're probably going to bring a fancy dancy chop saw to the job, one of those portable table saws, and do your best to cut everything as perfectly as possible. I've had to do that, and it's difficult. In fact, I've only done that fancy stairs a couple of times because there are. I came from a big city, Phoenix, and I think Eugene has one too, where I'm at now. There'll usually be in even a modest sized city, there'll be a company that specializes in expensive, fancy hardwood stairs with the rails and the whole business, and it's pretty hard to compete with their quality. It's very hard to compete with their quality. It's almost like factory made. So this is what you're learning here is how to lay it out and how to frame it as a framing carpenter would frame it. So thank you for watching, and I hope this video was informative and possibly useful. So again, thanks for watching.